This is the video lesson for Geometry Section 1.4, Measuring Angles. In this lesson, we're going to find and compare measures of angles. So an angle is basically two rays that have the same endpoint. They call that endpoint a vertex. Oops, wrong pen. Okay. So from this, say this was my point, and then we had a ray that goes off, and then from the same endpoint, another ray goes off. This here is the angle, right? And then this here has a measure. That you can see down below. We have different types of angles. They have different names for angles depending on their measurement of the angle between the two rays. And if it's between 0 and 90 degrees, it's called acute. If it's exactly 90 degrees, it's called a right angle. And if it's between 90 and 180, it's called obtuse. And if it's exactly 180, it's called a straight angle. It's also a line. Okay, so how do we measure and classify these? Let's look at an example. Here are some angles on a protractor. A protractor is a tool that you use to measure angles. So in this case, from 0 to 180. This first question is asking, what are the measures of, okay, LKN? So let's look at this first. We actually haven't learned how to name angles yet. And this is actually how you do name them. I thought the best way to do that was to show some examples. So they have this little symbol here that looks like an angle. That's telling you it's an angle. And it's saying LKN. What's that means is, if you start at point L and you go down, or you go to point K, and this would be helpful if this had a K. This is my K here. You go from L to K and then to N. That's the angle it's talking about here. So to name the angle, it's basically kind of tells you how to draw it, right? So start at L, go to K, and then end through N, right? So this is the angle, how you name that angle, LKN. And so the letter in the middle is always going to be the vertex, right? Or the end point of the two rays that create the angle. So in this case, it's asking, what's the measure here? What is the measure from 35 to 180? That would be our measure. So this is going to be 180 minus 35. So you measure them just like if this was on a number line, right? You just take the measurement and subtract them. So this is going to be 180 minus 35, which is 145 degrees. How do we classify that? Is it acute, right, obtuse, or straight? Since 145 is in between 90 and 180, it is obtuse. I'm sorry about my cursive writing. The tapping I know is annoying in these videos, so I'm trying to not tap my pencil as much. Okay. For angle JKL, that's this KL, we go from 35 to 90. So this is going to be 90 minus 35, which is 55. And that is in between 0 and 90, so acute. And then different color, JKN. So start at J, to K, and then end at N. Going from 90 to 180, so this is 180 minus 90, which is 90. And that's exactly 90, so it is a right angle. Okay, hopefully this isn't too bad. Oops. Let's go to the next slide. There should be one for you to try yourself, which is actually not very helpful because it should be on the other slide too, right? Let's see. Okay, there we go. Now we have the picture. So pause the video. Try these on your own. Find the measures and classify. Right, so find the measure and then classify for each one. Okay, and then come back and check your answers. Okay, so the first one was 35 and acute, the second was 180 and straight, and the third one was 145 and obtuse. Okay, oops, now that's that, isn't it? Let's make that go away, and let's bring this up. Okay, so a new vocabulary word, congruent angles. Congruent angles are angles with the same measure. So like we talked about in the last section about congruent segments, congruent angles are the same thing. They're actually angles that have the same measure. So while the two angles are not the same exact angle, if they have the same measure, they are called congruent. So let's see how we can use this in a problem. So in this picture, we have some triangles that form a polygon, and this says if GHJ is 45, so that's talking about GHJ here. What is KLM? So what is this here? So you can see, if we look closely, they both have this congruent mark here, and they match. This one has 2, this one has 2. That symbols say this angle is congruent to this angle. Okay, so since this angle is 45 degrees, then that means this one is also 45 degrees. Okay, that's all it means, right? Congruent angles have the same measure. I don't even think you need a pause your video for this one. If ABC is 49, what is DEF? Yes, also 49 degrees. Okay, moving on. The angle addition postulate. So this is similar to the segment addition postulate, where we add segments if they share a point. You add them together to get the total. Here we can add angles. So if they share the same ray here, right? So if this, so this angle here plus this angle here equals this whole angle here. You just add them together. So in this example here, right, if this is 45 degrees and this is 90, then this whole thing, right, is 45 plus 90, which is 135. Okay. So let's use this. I don't know why that didn't go with it. Okay, here. Let's use this to solve up an example. Okay, so if we have, oh, it's algebra, yay. We're going to use the angle addition postulate. If RQT, so this is telling me that this should be a Q, sorry about that, is 155, so RQT, so this whole thing is 155. What are the two angles, right? So that means RQ, right, RQS plus angle, the measure of angle RQS plus the measure of angle SQT equals the measure of angle RQT. And just a note about notation here, right, without this little m, this angle RQS is talking about that physical angle RQS, that angle. It's like its name. This little m in front means the measure. So that's the number, or the number of the angle. Right, so this is a number when you put an m. That's why you can add it and set it equal. Okay, so we know that the measure of RQS is the same as 4x minus 20 from the picture. We know the measure of SQT is 3x plus 14. So when we add them together, it should equal 155, right? Since the measure of RQT is 155. So now we just get to do algebra. Yay! Combine like terms. We have a 4x and a 3x. They combine to be 7x. We have a negative 20 and a 14. They combine to be negative 6. And they equal 155. So let's make our railroad tracks, and let's undo this minus 6 to get x alone. The opposite of minus is plus, so plus 6 on both sides of the railroad tracks. So these cancel. So we get 7x equals 155 plus 6 is 161. And then we're going to, let's put our railroad tracks back on. Want to undo this times 7, right? Multiplying here. So we're going to undo times by dividing. We're going to divide both sides by 7. So 161 divided by 7 is 23. Okay, so we're not done though yet, right? Let's look back to the question. It says, what's the measure of these two angles? We know what x is, but we don't know what the measures are yet. So let's take this x and plug it in to these x's here, right? So I'm going to do that over here. 4x minus 20 is the same as, since my x is 23, plug 23 in for x minus 20. So 23 times 4 is 92. 92 minus 20 is 72. So this guy is 72 degrees. RQS, 72 degrees. We can subtract 72 from 155. So we know this should be 83. since together this should be 155, but let's just do a double check right here and see 3x plus 14 just to make sure we got the right answer. This should equal, we're going to plug in our 23. 23 times 3 is 69 plus 14 hopefully is 83. Okay, so this is 83. Not too bad, right? Okay, so try this on your own. Sorry, this isn't moving with me. Okay, so try this one on your own. Pause the video. See if you can figure out what DEC... Oh, and actually you can't find what they are because I didn't write what DEC are. That would be good to know. DEC and CEF. Okay, now pause the video. Try to figure out what they are, and then check your answer, and we're done. Okay, so you should have gotten, I wrote it down here, 142 and 38. And if you add those together, you get 180. Yay. Okay, there you go.